The following short video shows you the results of the application of a classifier for microplastics. The data set is a hyperspectral image obtained from a freshwater sample which has been artificially spiked by 5 different polymer particles: polyethylene, PE, polypropylene, PP, polymethylmethacrylate, PMMA, polyacrylonitrile, PAN, and polystyrene, PS. The image exhibits a spatial resolution of 295 by 276 pixels, which amounts to approximately 80,000 spectra. We move the location cursor in the image to give you an impression of the spectra. At the right, you see the corresponding spectrum. A classifier for the aforementioned 5 polymers has been trained as described in a paper by Benedikt Hufnagel et al., which has been submitted to Analytical Methods of the Royal Society of Chemistry. Now let's perform the classification from scratch. In order to apply the classifier, we simply load it into the applicator form. This classifies all 80,000 spectra and delivers selective images for the 5 different polymer types. We can step through these images by selecting the corresponding class number. We have here PE, PP, PMMA, PAN, PS, and finally non-polymers. Let's have a closer look at PAN. Here we see the PAN fibers in the sample. We color these fibers by adjusting the color palette such that the fibers appear in the color cyan. In order to make it easier to recognize the particles, we now simply overlay the photo of the sample with the classification results. We can toggle the visibility of the results by clicking this checkbox. In this way, we can load all 5 polymer images using 5 different colors, ending up with an image stack of 5 layers on top of the sample photo. If we move the cursor to these colored spots, we see that we have here, for example, PP, which is shown in the color orange, or PS, which is indicated in green. The cyan threads are PAN fibers. Now let's zoom into this area where a PMMA particle covers the PAN fiber. Moving the cursor along the fiber first shows the PAN spectrum, then the PMMA spectrum shows up, and finally the PAN spectrum is visible again. A similar dataset has been published by Sebastian Primke et al. In order to improve the visibility of the classified particles, we show here roughly a quarter of the published data. When we apply our classifier to this dataset, we end up with a classification image shown here. As you can see, several PP, PE, and PMMA particles have been found in this rather dense sample, containing a lot of the other material including stones and coal particles.